Okay, following the previous video, I'd like to talk about, I'd like to solve a problem for you. Here, you have a circle here. Oh no, I mean, it's not really looking good. I mean, I'll have to use a different app here when I solve a problem. Paint, yeah, here we go. I think it's a bit better here, because I can actually draw a circle using, uh, this. Yeah, much better, right? So now you have a center, and then this problem asks you to get the a length of the chord. Okay, you need to get the length of the chord. First, let me explain what chord we need to get. So this is a circle whose radius is 2, and we need to get the length of this chord here. Okay, and then, all right, and then what is given is this. The radius here is 2. Like I said, hold on. The radius is 2. And then the length of the arc here is 3.4. Not the chord, the arc. The length of the arc is 3.4. Okay. I want you to pause the video and try solving this on your own. Okay? And yeah, my the only hint that I can give you is that the circumference is 2 pi r, and the circumference, and if you want to get like a part of a circumference, um, that's related with angles. I talked about that in the previous video when I explained radian, right? Radian has to do with the angle, right? Radian has everything to do with the angle. So how about you pause the video and solve this on your own? So you need to get the length of the chord, which is from, I will actually mark that in red. Hold on. Uh, you need to get the length of the chord from, from here to here. Okay, you need to get the length of the red line. Okay? Okay. Pause the video, and I'll solve it now. Okay, I assume that you solved it. So as you know, let's put this as theta. Okay? Then you know that the height of this right triangle here is, no, the base of the right triangle here is 2 cosine theta, and then the height of this right triangle here, this part from here to here, is 2 sine theta. Okay, so then you know that the length of the chord is going to be represented in sine. So the length of the chord, the red line, is 4 times sine theta, right? But we want to know what theta here is. But as you know, theta here is an angle, not a radian. So as you see, we need to turn this degree into radians so that we can match with the answer choices that is given. Okay. Uh, Hold on a second, please. I think I did something wrong here. Uh, oh no, actually, yeah. So you need to get this theta first, and then turn it into radians. So theta, like I said, is given in degree. degree, but like theta is a degree, and you need to turn this into radian, right? Now, how do you do that? First, first, if degree is 360, you know that the radian has to do with the circumference, right? It's 2 pi r. So for 360, the radian is not actually not 2 pi r, it's 2 pi. So what I'm saying is 360 is 2 pi. Then we want to know if this is theta, then what is what is this r question mark? So 360, you just divide both sides by 360, then you have 1 degree here, and then this is going to be 2 pi over 360, right? Since we have 2, we can simplify that to pi over 180. So as you see, 1 degree is pi over 180, right? You need to know. So what this is saying is, if you multiply if you multiply pi over 180 to a degree, then you will get a radian of that, right? So for example, like as you know, 360, this one itself in radian is 2 pi. So think about multiplying pi over 180 to that, right? Then you will get 2 pi exactly. You know what I mean? So why did I do this? Because I want to turn degree into a usable number, like a real number. Like I said, a radian is a real number. So now let's try solving this one here. So as you know, the angle here is 2 theta, right? The angle here is 2 theta, right? And you know that if the angle here is given is the whole circle, then it is 360 degrees, right? For 360 degrees, it matches with the circumference, which is 2 pi times 2, which is 4 pi, right? So 360 represents, so what I'm saying is the angle here, 360 degrees, matches with the circumference. Okay? Now then, if it is 180, then what is it? 180 is this, and it definitely matches with the part of the circumference, which is the half of the circumference. So it's going to be 2 pi times 2 divided by 1 over 2, because 180 is half of the circumference. Therefore, this is just 2 pi. But now what we're looking for is 2 theta, right? 2 theta. Then what do we want to do? Okay, we want to do 2 theta divided by 360 times 4 pi, right? Then we can get the length of the angle here. The length of the no, not the length of the angle, sorry. The We know that if this is 2 pi, 2 theta, then this here matches with 3.4, right? 3.4. This one matches with 3.4. So 2 theta over 360. This, if you simplify that, then you have 180, and then you simplify that with 4. Then this 290, and this is 45. So you have theta is theta over 45 times pi is 3.4, right? So all you need to do now is solve this for theta. Okay. Because theta is what we want to get, right? So now then, hold on a second, please. I need to erase this a little bit.